morning, Chem I. I am caffeinated and ready to go and do some gas law stuff with you today. Before we get started, just kind of some background, I think, where we're heading. We're in day 3 now. I'm trying to record these a day ahead from when I release them to you. And I think I'm starting to get an idea of how this is all going to work. Typically in class, I would go over a PowerPoint or something. I know we would do labs. I'm really kind of disappointed because there's a bunch of cool labs that Gas Laws has that we're not going to get to do. I'm going to try to attach videos of some cooler demonstrations and things that we would typically do in class. They're more optional, but they do kind of hammer home some of the content that we're going to be discussing specifically in this PowerPoint. Another thing is you might be starting to wonder about grades. Grade-wise, what I think we're going to do is I think Friday is just going to become our quiz day, or the end of the week is going to become a quiz day. And what I'll do is I'll take everything that we've covered that week and I'm going to make a Google form quiz. So, and it'll just be my way to kind of like hold you accountable. It will more than likely be multiple choice, or there might be some with like that are free response that require sig figs or something like that. But because most of what we're going to be asking you about is questions, our math problems, because that's a lot of what Gas Laws is. But I think that'll just be a way that we can get a grade in, kind of hold you accountable. Once again, you will have the notes available to you. You'll have all the practice problems available to you. This is going to be essentially an open note take-home quiz. You're going to have as long as you need. Now, you'll only be able to get into the quiz once, but I would imagine, as long as you're being diligent through this week, you should be fine. Okay. So it just gives me some kind of accountability piece so that you're making sure you're going through these notes and staying on top of things. So with that being said, let's get started with some gas laws. This is the meat and potatoes of this section. Okay. I will say this, there's a lot of math, but you will find that this math is much more straightforward than stoic. It's literally about identifying variables, and there are only 3 variables that we're going to deal with. The first variable, if my pen will write, is pressure. The second variable is volume, and the third variable is temperature. And basically, these are all just equations that have that show the relationship between pressure and volume and temperature. And some of these you already understand. If you increase the temperature of a certain volume of gas, it's going to expand. You already know this, okay? We're just putting mathematical relationships to these things. So, with that being said, let's proceed. These two, I'm going to try to find YouTube videos so you can see what these are. They're pretty cool demos. One of them you could probably do at your house. The other one you probably can't. But you could make a Cartesian diaper if you wanted to try to do that, okay? So, with that being said, if we're going to talk about gas laws in this math, you need to understand something called STP, or standard conditions. Anytime I say change this to STP, or such and such a gas is at STP, that's me telling you the standard temperature and pressure. The standard temperature is 0 degrees Celsius, and the standard pressure would be 1 atmosphere, or 760 millimeters of mercury. Remember, yesterday we talked about those 2 units of measure for pressure. We also know that 1 mole of any gas will occupy a standard volume of 22.4 liters, but that would not, if I said STP, I'm not talking, clearly there's no V in there, so it's just standard temperature and pressure, okay? The first law we're going to use is called Boyle's law, and it's saying that the pressure and volume are inversely proportional. And what that means is if we set P and V equal to a constant, if the pressure increases, in order for that constant to stay the same, that means the volume is going to have to go down. And if you stop focusing on the fancy words for a second, that makes sense. If I have a balloon and I increase the pressure on that balloon, guess what? It gets smaller, okay? It's kind of what's happening down here. We have a high pressure pushing inward, and that's going to decrease the volume of this gas. It's going to become more compact. If I decrease the pressure, then guess what? Volume increases, okay? So they're inversely proportional in Boyle's law. So how does that help us? Well, we can do problems then where we set one, like situation 1, P1, V1, equal to situation 2, B2V2, or P2V2, if the pressure or volume is changing. So if we read this, it says the volume of a gas at 0.977 atmospheres is 300 milliliters. What is the new volume if the pressure is increased to 1.86 atmospheres? So we're changing the atmospheres. The first thing you should always do is identify your variables. So the first thing you do is say, okay, atmospheres, that's a pressure. We're going to call this P1. And at that pressure, it's at this volume, that's milliliters, so that's V1. And then it's changing to a different pressure, that's P2. All right? Once you identify and those variables, you'll say, all right, we're dealing with pressure and volume here. That means I need the equation that deals with pressure and volume, which is Boyle's law. Okay? So the first thing I would do is, sorry, I'm off camera, is go P1 V1 equals P2 V2, and we've identified our variables, so then you're just plugging stuff in. 97 times 300.0 equals 1.86 times, and we don't know what V2 is. This is basic algebra, people. I need to get V2 by itself. I'm going to divide by 186, or 1.86, and that will give me V2 equals, and it already says it over here. Sneak attack, okay? It's 158 milliliters, all right? If you do that math out, 0.977, and it's just, and that makes sense, okay? Look, the pressure is increasing. It's almost doubling. So that means, and since these are inversely proportional, that means the volume should go down by almost double. And guess what? That's exactly what happens. So you can kind of, if you understand ratios, you can kind of check your work here, okay, as you do the math. All right, so this is Boyle's law. Here's another example. In this case, we see it's going from this volume, V1, to this volume, V2, all right? Notice something. I just labeled the volumes backwards from what it is in the problem. That's okay. It does not matter which one's V1 and which one's V2, as long as you pair the right pressure with the right volume. So for instance, here I'll change it just to make it more clear based on what's on the slide. This is V2, and we're calling this V1. The initial pressure is 0.98 atmospheres. That means that this pressure is paired with this volume because it's going from that volume to the 0.05 liters. Okay, so you got to make sure that if you call 4 liters V2, then that means this pressure has to be P2. Okay? Once again, you'd set up your problem since we have pressure and volume, P1, V1. We don't know P1. V1 is 0.05. P2 is 0.98. And V2 is 4.00. We're going to divide by 0.05. Okay? And that would give us 78.4 atmospheres. Okay? So the math, I would say this is less about the math, and this is more about, can you identify what variables you have and just put them in the right spot? You're going to have these equations available to you. It's on an equation sheet. Okay? So you should be good. Law number 2. We also know, so we know that pressure affects the volume of a gas. We also know that temperature will affect the volume of a gas, but that is directly proportional. What that means is that so if we want to set this equal to a constant, if the volume goes up, the only way for it to be set equal to a constant, the temperature would have to go up as well. Okay, or as the temperature goes up, things expand, another way to think about that. So these are directly proportional. Here's the key. Temperature, anytime during gas laws, you're given a temperature, it has to be in Kelvin. Why is that? Well, because Celsius has negative numbers. And that's a no-no, okay? These are ratios, and if you start introducing negative numbers, it's going to screw up the ratio. So we have to operate in Kelvin, where absolute zero is 0. The easiest way to remember this, and this is on your equation sheet, if you need to get to Kelvin from Celsius, just add 273. I know it says 273.15 here. 273, okay? That's what we're doing. If I give you a Celsius temperature, add 273, okay? This is a diagram of what Charles' law would look like. If I put a gas in a valve here, and I heat up that gas, it's going to expand. As temperature goes up, volume goes up, okay? Charles' law. All right, so here's our equation. If a gas occupies 2.3 liters right now, that's V1. At 40 degrees Celsius, that's T1. Those two are tied together. What is the new volume? Sorry, I'm not being very clear here. T1. What is the new volume at 75 degrees Celsius? That's T2. Okay? So what you need to do is, first of all, you need to understand we're looking for V2. Okay? But if you look, I gave you two temperatures in Celsius. We need to change those immediately. Okay? So we would take 40 and we'd add 273 and we'd get 313. We'd take 75 and we'd add 273 and we'd get 348. Okay? Another part of this is seeing and recognizing we have volume and temperature. Okay? So that means we need the equation that's volume and temperature. V2, T2. Okay? So that would give us 232 over 313 equals V2, which we don't know, over 348. Okay? The best way with Charles' law, since you have something on the denominator, cross multiply. But I would argue you don't need to cross multiply both sides. Just divide this out and then cross multiply this. So if you're typing that into your calculator, 232 divided by 313 times 348. And that will give you V2, which is 2.58 liters. That makes sense too. Why? Because the temperature went up, and therefore the volume should go up. Okay? Because these are directly proportional. Okay? Here's another one down here at the bottom. Here, let me erase some of my ink here. Okay, we have a volume changing and a new temperature. All right. The V1 is 0.67. Let me talk about how to solve this because it's a little different algebra. 362 is on the bottom. You got 1.12 and T2 on the bottom over here. Because your variable's on the bottom, you have to get it out of the denominator here. Okay? I would still divide this out and then I'd bring T2 across. What that would give you, if we take 0.67 divided by 362, that'd give you 0.00185, and then times T2 equals 1.12, and then we divide that side by 0.000185. Okay, 0.00185. All right, and that would give us our answer, which is, well, it was 605 Kelvin, and then we subtracted 273 because it asked for what is the final temperature in Celsius. Okay? Make sense? It's not, I do think this is simpler than stoic. It's just find the variables. All right, I'm going to start moving a little quicker here. Gay-Lussac's law is pressure and temperature. How does temperature affect pressure? And this is another one that you should understand. If I throw, what do we always say? Don't heat a closed container. Why? Because if volume is fixed, pressure is going to build. If you throw an aerosol can into a burning barrel, don't do that. It will expand and become dangerous, right? It's going to want to explode. Okay? These, once again, it's just P1 over T1. They're directly proportional. As temperature increases, pressure increases. Okay? So we have our variables here. We're going to plug them in, okay, and we're going to get our answer. Same thing down here. You're just taking P1. If you're going to set these up, it's 3.20 over 295. Remember, we always have to use Kelvin. And then P2 we don't know, and 333 on the bottom. Okay, and you're just solving for P2. Very simple math, okay? As long as you've mastered basic algebra, you should be okay here, okay? Be able to convert it back to Celsius if you need to, all right? I'm not going to, they're similar enough to the last problems. I'm not just going to pound like walk through every little thing. If you need me to, ask a question. We can I can make a video to show you specific problems if you need that, okay? There's one more. The combined gas law is obviously all three of them combined, pressure, volume, and temperature. And they still maintain the same ratios that we just talked about. P1, V1 are on top, and T1, T2 are on the bottom. Remember, temperatures must be in Kelvin. The way you'll be able to recognize these is because you'll be given pressures and temperatures and volumes. Okay, look, it says a sample of neon says 30 milliliters at STP. That is telling you vital information. At standard temperature, 0 degrees Celsius, which is 273 Kelvin. At standard pressure, which is 1 atmosphere or 760, let's just use atmospheres because it doesn't say, okay, at 1 atmosphere. So if it says STP, it's telling you the temperature and pressure. Remember, that's the first slide, okay? Which makes this V1, we'll call this T1, we'll call this P1, and then the new temperature would be 303 Kelvin, because we're adding 273, that's T2, and this is V2. So if we look at our, we know, so the second we identify, oh, we have all three variables here, it's combined gas law, okay? So we got P1, which is 1 atmosphere. We got V1, which is 30 milliliters. We have T1, which is 273. We have P2, which we do not know because it asks us for the new pressure. We have V2, which is 20 milliliters. And we have the new temperature, which is 303. I would do this first, then I would cross multiply, and then I'm going to divide by 20. And if you do that, you would get 1.66 atmospheres. Okay? Does everybody understand what's, well, I know, I'm so used to teaching. I'm asking you questions and you're like, watch it on YouTube. All right? So if you do have questions, send me an email. Tell me you need me to work through this problem. Okay? I can make a video real quick and show it to you. Okay? But I think we're okay here. Same thing here. Okay, just identify the variables, plug them in. All right. Anytime something says correct to STP, okay, this means find the volume at STP. It's telling you that this is V1, T1, and P1. This is in millimeters of mercury. And it wants you to correct to STP, which is 273 Kelvin. And the standard pressure at millimeters of mercury would be 760. You can't use atmospheres now because we already were given the pressure in millimeters of mercury. So you have to stay in millimeters of mercury for your standard pressure. Okay? But once again, there's what you should be looking at in terms of your labeling. And then you're just plugging them in and solving for your answer. Okay? I don't want to take up I want you to just have to sit there and watch me work through problems. If you understand. But if you don't, please reach out, ask me questions. All right, I want to show you a couple more things here real quick. The first thing, this right here is a chart that I'm going to attach to the assignment. It breaks down the gas laws and it shows you what they look like. It gives you a description. It shows you the variables and the units. We talked about Dalton's law already of partial pressures. Graham's law is not on here, okay, with the first day. But we made it all the way through combined gas law today, okay? And it shows you what they are. You will have this available to you like if you take a quiz, okay? And look, I tell you the units to be looking for. If it says, basically this is a really helpful thing. You can print it off. You can look at it during a quiz or whatever. You can look at it when you're doing your homework, okay? But I would not get in the habit of waiting to do these problems and learn how to do these problems till the day the quiz comes out. I think you're going to want to give yourself time to ask questions and figure out what's going on. If you look at the homework today, it's broken down into Boyle's law, some Charles law problems, Gay-Lussac, and then combined gas law. Okay, the answers are down the bottom. If you want to see them worked out, it's on the website. Okay, so all of this stuff's available to you. I would be in the habit of working through these things. I don't know when we're going back to school, so I don't know when I'm going to get to look at this or give a grade for this. Your grades are probably going to come from these Friday quizzes where to start, but you can guarantee that this Friday quiz will have a Boyle's law problem, it's going to have a Charles law problem, it's going to have a Gay-Lussac's law problem, and it's going to have a combined gas law. Okay, so familiar yourself with how to do them now so that when you get to the quiz, it's like, okay, I know what I'm doing here. Okay, That's enough for today, I think. Good job. Once again, reach out to me, ask me questions if you're struggling. We're going to kind of space some of the rest of this out. This is the last lesson for this week. The only thing else you'll have is just the quiz on Friday. Okay? We will see you soon. Be good to somebody today. I appreciate your work. Keep it up.